Work energy and power. Question 6. A 20 kg block is released from rest from the top of a ramp at point A at a construction site as shown in the diagram, meaning the velocity of our block at point A is 0 meters per second. The ramp is inclined at an angle of 30 degrees to the horizontal and its top is at a height of 5 meters above the ground. 6.1. State the principle of conservation of mechanical energy in words. Now, the principle of conservation of mechanical energy states that the total mechanical energy, which is the sum of kinetic energy and potential energy in an isolated system remains constant. 6.2. The kinetic frictional force between the 20 kg block and the surface of the ramp is 30 newtons. Use energy principles to calculate the 6.2.1 work done by the kinetic frictional force on the block. Work done by kinetic frictional force is equal to kinetic frictional force times displacement times the angle between the displacement and the force. But in this scenario, we were not given the displacement of our block, which is this length. So we're going to have to calculate it using trigonometry. So we have a right angle triangle. The height above the ground is 5 meters long. The angle is 30 degrees and our displacement is the hypotenuse. So we have so we have opposite and we're looking for the hypotenuse. So we're going to use sine. Sine theta is equal to opposite over hypotenuse. Now our theta is 30 degrees is equal to opposite is 5 meters divided by delta x. Sine of 30 is divided by 1, so we're going to cross multiply. 5 is going to multiply with 1 and sine of 30 is going to multiply with delta x. We will be having delta x sine of 30 degrees is equal to 5. Now we want to make delta x the subject of the formula. So we're going to divide by sine of 30 and divide by sine of 30 on this side. Our displacement is equal to 5 divided by sine of 30. Work done by frictional force is equal to 30 newtons. 30 times our displacement is 5 divided by sine of 30 times. Now what is the angle between our displacement and our force? So our object is sliding down this slope, right? So the direction of the displacement is this way and the frictional force is opposing the direction of the motion of our object, so it is this way. What is the angle between the displacement and the force? It is 180 degrees, so we're going to say times cos of 180 degrees. When we plug that into our calculator, we get 30 into 5 divided by sine of 30 times cos of 180 is equal to -1. We get -300 newtons up the slope. 6.2.2. Use energy principles to calculate the speed of the block at point B at the bottom of the ramp. Now, in order for us to understand the scenario, we're going to have to draw the free body diagram. So we have normal force, and we also indicate the components of our weight. We have weight perpendicular and we have weight parallel. Then we also have frictional force. Now, since they want us to calculate the final velocity, which is the velocity of our block when it reaches point B, what is the formula that comes to mind that has something to do with kinetic energy, because kinetic energy has something to do with velocity. It is the formula for W net is equal to change in EK. Now, what are the forces that are doing work on our object? It is the forces that lie in the same direction as the displacement of our object, which is weight parallel and frictional force. So we have work done by weight parallel plus work done by frictional force is equal to half m v final squared minus v initial squared. Now W parallel is mg sine theta. So we have mg sine theta times displacement times the angle between the force and the displacement plus work done by friction. Work done by frictional force is this one we calculated in 6.2.1, so we don't have to expand this formula. 1/2. The mass of our object is 20. Now the V final, that's what we're looking for, so we leave it as is. Now our V initial was 0 because they told us that our object is released from rest. So our V initial is 0 squared. So our mass is 20 times the gravitational acceleration sine of this angle is for the inclination 30 times our displacement is this 5 divided by sine of 30 degrees times the angle between our force and our displacement. Weight parallel is going to the same direction as our displacement. So what is the angle between our displacement and the direction of our force? It is 0 degrees because they're both going in the same direction. So we have cos of 0 degrees plus negative 300. Negative 300 is equal to half of 20 is 10 times V final squared because 0 to the power of 2 is 0. Now when we plug this whole thing into our calculator, we get 680 is equal to 10 V final squared. Now we're going to divide by 10 and divide by 10. Now in order for us to get rid of the squared, we are going to put the whole thing inside of a square root. This 10 is going to cancel with that one, so we will be having V final is equal to square root of 680 divided by 10. We get 8.25 meters per second. That is the velocity of our object at point B. 6.3. A 100 kilogram object is pulled up the same ramp at a constant speed of 2 meters per second by a small motor. The kinetic frictional force between the 100 kg object and the surface of the ramp is 25 newtons. Calculate the average power delivered by the small motor in the pulling of the object up the incline. We're going to draw our scenario because they just gave us words. We have our object and it is being pulled by a motor, right? So our object weighs 100 kilograms. We have an angle of 30 degrees and a height of 5 meters. So they say calculate the average power delivered by the small motor. So the formula that I want you to think about is this one. Average power is equal to the force causing our object to move, which is the force of the motor, times the average velocity, which is 2 meters per second. So we have the value of our average velocity, but we don't have the value of the force that is causing our block to move, which is the force of the motor. So we're going to use Newtonian motion. F net is equal to ma. Up the incline as positive. Now since they told us that at a constant speed of 2 meters per second, there is no acceleration, but nobody wonders why acceleration is actually equal to 0. In this video, I'm going to explain why we always say acceleration is 0 when we have constant velocity. So we define acceleration by saying acceleration is equal to the rate of change of velocity, meaning we see how much velocity changes over time. So when our object is moving at a constant velocity, change in velocity is v final minus v initial, right, divided by delta t. For this instance, let's say we want to see how our object accelerates in 7 seconds. So since our velocity is constant, v final should be equal to v initial, right? So it is 2 minus 2 divided by 7 seconds. Now 2 minus 2 is 0. So the answer here is 0. So our acceleration is 0 meters per second per second. That is why we always say acceleration is 0 when we have constant velocity. F net is equal to 0 because acceleration is 0 because we have constant velocity. Now we need to draw a free body diagram showing all the forces acting on our block. So we have the force delivered by the motor, we have normal force acting perpendicular to the surface, then we have the perpendicular component of the weight, and we have the parallel component of the weight. Then our object is being pulled up the same ramp, so the direction of friction is this way. Frictional force up the incline is positive, so we have force delivered by the motor minus W parallel minus frictional force is equal to 0. Weight parallel plus frictional force. Force delivered by the motor is equal to mg sine theta plus Fk. Now what is the mass of our object? It is 100 kilograms. 100 into 9,8, that's the gravitational acceleration. Sine of the angle is still 30 degrees plus. They told us that the kinetic frictional force between the 100 kg object and the surface of the ramp is 25 newtons. So we have plus 25. 100 into 9,8 times sine of 30 plus 25. 515 newtons up the slope. Now we know the value of the force delivered by the motor. So we have average power is equal to the force causing our block to move up the incline times the average velocity. We have 515 times, we are told that our block is moving at a constant velocity of 2 meters per second. Answer times 2 is 1030 watts. That's our final answer. Thank you for watching.